Hello my fellow working class heroes, good day. I am Carlo and welcome to Carlo Excels. These are the objectives of this episode. Today we continue with the if series. Now this is the second episode of our if series here in Carlo Excels, and today we're talking about the nested if functions. We're gonna start with the definitions first and then using the nested if functions and then the applications of the nested if functions. Before we continue, let me first say that this particular lesson presupposes or assumes that you've already seen and learned the basics of the if function. If you haven't learned the basics of the if function yet, please proceed to the lower part of this video, to the descriptions area. In the descriptions area, you will find a link to the lesson on the basics if function. Please check that out first. If you've already seen the video on the basics of the if function, this is just a short review. The if function returns one value if a condition you specify evaluates to true and another value if that condition evaluates to false. For the if function, the function name is if, and for your function arguments, you have your logical test, and then your value if true, and then value if false. From our previous lesson on the basics of the if function, this is the structure of the if function that we've been dealing with so far. So you have here your logical test, so you basically ask Excel a question. Is this particular statement or logical test true or false? If it is true, you get one outcome, and if it is false, you get another outcome. But of course, in Excel, just like in real life, problems or questions are rarely ever binary. Problems are rarely ever answered by a simple true or false, a yes or no, a black and white, a red or green, things like that. Sometimes you need more than just one outcome, and if you have more than one outcome, therefore you're going to need Microsoft Excel to evaluate multiple logical tests. Just like what you can see on the screen right now. Here's one example. You have one question that you want Microsoft Excel to evaluate, and Excel evaluates it as true or false. If the first question turns out to be true, just like what you can see on the screen, then you ask Microsoft Excel to evaluate another question, which it will then evaluate as true or false. If the second question turns out to be true, then Microsoft Excel produces an outcome. If it turns out to be false, then Microsoft Excel produces another outcome. But if the first question turns out to be false all the while, then you have your third outcome. Here's another example of multiple outcomes. A bit different but more or less the same. So you have Microsoft Excel evaluating one question. If it turns out to be true, then you directly have an outcome. But if Microsoft Excel evaluates it to be false, then you proceed to the second question, which Microsoft Excel will then evaluate as true or false, thus producing your second and your third outcome. Now in this case, you now have more than 3 outcomes, and the logic now looks like what you see on the screen. You have Microsoft Excel having to answer the first question. If it evaluates to true, Microsoft Excel will have to answer another question. If the first question evaluates to false, then Microsoft Excel will then evaluate another question. Both the second and the third questions here branch out to both true and false. Thus, you get 4 outcomes total. And yes, of course, you may have many more outcomes than that, with outcomes and logical tests branching out in completely complicated manners. This is what decision-making in real life looks like. It is far more complicated than just true or false, or black or white, or yes or no, or red or green. It is a chain of multiple questions which you will have to answer. And thankfully, we can do this as well with Microsoft Excel. To understand how you have multiple if statements branching out from one another, let us first review the basic structure of the if function. First, we have the logical test. This is just a review from what we learned during the previous lesson. The logical test is a question that you ask Excel, which Excel can answer with either true or false. It can be a basic logical operator or a logical function. Next argument, the value if true. This is what Excel will do or display on the cell if the logical test is true. The value if true can be a constant value, a constant text, a cell reference, a formula, or a function. Now, I want you to pay close attention to the last part of this definition. In other words, the value if true can be a function. In other words, after the logical test turns out to be true, the value if true can be a sum function, an average A function, a trim function, an upper function, and yes, even another if function. Again, if the first logical test turns out to be true, the value if true can be in fact another if function. Third argument, we have the value if false. Now, the value if false is, this is what Excel will do or display on the cell if the logical test is false. This can be a constant value, a constant text, cell reference, a formula, or a function. Once again, please pay close attention to the last part of the definition. The value if false can be a function. In other words, if the logical test turns out to be false, then the value if false will execute. So the value if false can be the sum function, the average function, and yes, even another if function. Again, if the logical test turns out to be false, then the value if false can be branched into another if function. So let's have a sample of that. So for example, you have here on the screen two logical tests. So you have the first logical test, and this is what happens, value if true 1. This is what happens to the cell if the first logical test is true. This is what happens to the cell for value if false 1 if the first logical test is false, right? Then you have the second logical test. So logical test 2. The value if true 2 is what happens if the second logical test is true. And the value if false 2 is what happens if the second logical test is false. So what if this example we had a while ago is what you want to happen? In other words, you want Microsoft Excel to do a first logical test, and if the first logical test is true, then the second logical test kicks in, just like what you can see on the diagram. Then Microsoft Excel evaluates that as either true or false, but if the first logical test is false, then Microsoft Excel proceeds with another outcome. So in other words, going back to our slide a while ago, what you want to happen is, as soon as logical test 1 becomes true, then Microsoft Excel proceeds to logical test true and tests this particular if function. But if this is false, then you want Microsoft Excel to immediately proceed to this value if false 1 here. So how do you write that in function form? Well, actually, that's not hard. Remember, again, value if true over here can be a function. So therefore, all you will have to do is replace value if true 1, like take all of the value if true 1, take all of that out, and then insert this second if function into this argument here. So what you will get looks like this. You will see now that the first logical test is over here. The first logical test is over here, and once this evaluates as true, what used to be the argument for value if true is now replaced by the second if function, just like what you can see on the screen right now. So again, to compare, as soon as the first logical test is done, the second if function automatically kicks in. So essentially what you did is you inserted an if function within another if function. So I hope you remember in one of our earliest lessons here in Carlo Excels, during our lesson on the basics of functions, we have a term for this. We call this nesting. When you put a function as an argument within another function, what you have there is a nested function. So this process of putting an if function within another if function is called nesting if functions. So let's have an example of that particular situation. Now, let's have Microsoft Excel evaluate one particular value over here. And we ask Microsoft Excel, is the value less than or equal to 50? If it is less than or equal to 50, then Microsoft Excel will further test. Is it then less than or equal to 10? If it's less than or equal to 10, then we have Microsoft Excel display the value is 10 or less. And then we have that as outcome A. If the value is not less than 10, less than or equal to 10, then we have Microsoft Excel display this message here. The value is greater than 10 but less than 50. But if the value is greater than 50, then of course the first logical test is false, and then we have Microsoft Excel display the value is greater than 50. Now we're finally here at Microsoft Excel, so let's do the nested if functions for this example. So you have here, just like what was discussed a while ago, the various outcomes. These are the conditions or the logical tests for the outcome, and this is where we input the number, and this is where the result is supposed to appear. So before we continue, for explanation's sake, let's use the bottom part of this Excel sheet as some sort of scratch paper, and let's proceed to doing the first logical test. So now we call out the if function doing the first logical test, so equals and then if. So remember during the previous slide, the first logical test was, is the value less than or equal to 50? So we click on this, is this value going to be less than or equal to 50? So that is your logical test. And then let's enter the value if true. For now, let's put in a constant text data to signify true, like so. And then let's put in the value if false. The value if false is this. So therefore, if A2 is not less than or equal to 50, so therefore it is greater than 50. So if it is greater than 50, then Microsoft Excel is supposed to display this statement here. The statement on cell D8, which says the value is greater than 50. And when we close the quotation mark and then press enter, you have here the value evaluating as true, because of course the cell is still 0, so because there's nothing in it yet. So let's try it. Let's put in a small value like 12, not less, still less than or equal to 50. Let's put in 20, still less than or equal to 50. 30, still. 40, still. 50, still less than or equal to 50. But the moment we put in here 51, which is already greater than 50, you will notice that the if statement is working as intended. The value is now greater than 50. So let's clear that, and then we proceed to our second logical test. If you remember from the previous slide, our second logical test was like this. If, and then the one we wanted to test was, is A2 less than or equal to 10? So that is our logical test. If it is true, therefore if the value is less than or equal to 10, then we want this message to show, the value on cell D2, which says the value is 10 or less. And then if the statement is false, in other words, if the value is greater than 10, then we want this message to show, which is the outcome on cell D5, which says the value is greater than 10 but less than 50. So then we close quotation mark and then press enter. Now we can try this. So right now it says the value is 10 or less because once again the input here space is still blank. Cell A2 is still blank, so therefore it's 0. So if it is 0, it still says the value is 10 or less. So as we approach 10, it still says 10 or less. So 9 still says 10 or less. When we have 10 over here, it still says 10 or less. But when we do 11 here, it is now greater than 10 but less than 50. Now we have both logical tests and it's time to nest them. So once again, all you have to do is to take the second logical test here, take this logical test here, and insert it where the value if true argument is supposed to be on the other logical test or in the other if function. So let's take this statement here and then let's copy that and then go to the first if statement and then replace what used to be the true argument here. Let's replace that and then paste the argument here. So this is what it will look like now. So if A2 is less than or equal to 50, proceed to the next if function and check if A2 is less than or equal to 10. If it is less than or equal to 10, proceed to show cell D2. If it is not, proceed to showing what is in cell D5. And then if cell A2 is greater than 50, then proceed to showing what's in cell D8. So let's press enter on that, and that is now your nested if function here. So let's take this formula here and put it where it's supposed to be, where this result space over here. Let's put the formula there, and then you have here our result. Now let's try this out. Right now, the blank is still blank. Therefore, there is no value here. It is still 0. So if I have 0, the value is 10 or less. If you have something like 5, value is still 10 or less. 9, the value is still 10 or less. 10, the value is still 10 or less. But the moment you approach 11, it already says the value is greater than 10 but less than 50. Meaning it is already showing outcome B. Let's approach 50 now. Let's have here 20. Value is still greater than 10 but less than 50. 30. Value is still greater than 10 but less than 50. 40. 50. Value is still greater than 10 but less than 50. But the moment you go 51, it now changes to the value is greater than 50. So in other words, we have now achieved these logical statements here. So this is how we did nested if functions by replacing the value if true on the first logical test. For this next example, let's try out this particular structure of logical tests. So you have here the first logical test, which we have Microsoft Excel evaluate. If it is true, proceed to outcome A. If it is false, then proceed to another logical test and then evaluate that as true, which will turn out to be the next outcome, and then false, which will turn out to be another outcome. So going back to what was mentioned a while ago, these are our two logical tests. So you have logical test 1, and then if logical test 1 is true, then you have value if true 1. If it is false, then we have value if false 1. Then we have a second logical test. If it is true, then you have value if true 2. And if it is false, then you have value if false 2. So essentially in this example, what we want to do is, just like what we did during the previous example, this time we want to replace the value if false 1. Because if the first logical test, if logical test 1 turns out to be true, then we execute value if true 1. But if it is false, then we want logical test 2 to kick in. So therefore, just like what we did a while ago, we replace value if false 1. This whole argument here, we replace with a function. In this case, we nest the second if function. So this is what it's going to look like now. So in this case, you will see if logical test 1 is true, then execute value if true 1. But if it is false, what used to be value if false 1 has now been replaced by another if function, which is the second if function. So therefore, if logical test 1 is false, then try checking if logical test 2 is true. If it is true, then execute value if true 2. If it is false, then execute value if false 2. Now let's try out this example here. So we have here our first logical test. Let's check if a value is greater than 10. If it is greater than 10, then of course we have the statement being true. Then we have Microsoft Excel say the value is greater than 10. This will be outcome A, just like what you can see on the screen. If the value is not greater than 10, of course this turns out to be false because the value is less than or equal to 10. Then we proceed to the second logical test. The second logical test checks if the value is greater than 5. If the value is greater than 5, then we have Microsoft Excel display the statement, the value is greater than 5 but less than or equal to 10. But if this is false as well, then we have Microsoft Excel display, the value is 5 or less. This will be outcome B, and this will be outcome C. Now we're back here at Microsoft Excel. So just like what we showed during the previous slide, this is where we input our value. This is where the result is supposed to be shown. Now, these are your outcomes. These are the messages that we want Microsoft Excel to display. So let's first write down, a scratch paper, the logical tests, the if functions here below in these spaces right here. So let's do first the first if function. So calling out the if function if, and then of course logical test. Again, the logical test is cell A2, where we're supposed to enter the value, is cell A2 greater than 10? Right? Then we enter the value if true. If cell A2 is greater than 10, then we display this message, the value is greater than 10. If it is false, for now, let us insert a text message which says the word false, like so. We do this for now. And then, close quotation mark, press enter. Now we try this out. So, right now, the value again is still 0 because it's still blank. So, it still displays false because it's not 0 is not greater than 10. So, let's try 1, not greater than 10. 2, not greater than 10. 6 is not greater than 10. 9 is not greater than 10. 10 is not greater than 10. But the moment we put in here 11, now the if function states the value is greater than 10. So now we know that it works as planned. Next, we do the second if function. So calling out the if function, our next logical test is the value greater than 5? So is this greater than 5? If that is greater than 5, then we want this message to kick in. So we use this cell reference right here and then press comma. But if it is not greater than 5, then we want this statement to kick in. And then close quotation mark, press enter. Right now, once again, this is still blank, so it's still 0. And of course, 0 is the value is 5 or less because 0 is 5 or less. So let's try this out. Press 1 here, nothing. Press 2 here, value is still 5 or less. 4, the value is still 5 or less. 5, the value is still 5 or less. But the moment we press 6, the value is now greater than 5 but less than or equal to 10. So now we know that this particular if statement works. So now once again, we want to nest the second if function within the first if function. So once again, what we do is, this is the second if function. We copy that. And then what we do is, where the second false statement is supposed to be, here, we replace with the second if function. So therefore, this if function is what will happen when the first logical test turns out to be false. So let's take that formula here, and then let's put it right here, and then press enter. Right now, it still says the value is 5 or less. So, it's still 0, of course. Then let's try 1, value is still 5 or less. 3, value is still 5 or less. 5, the value is still 5 or less. The moment you put in 7 or 6 here, the value is now greater than 5 but less than or equal to 10. So, let's try 8, still greater than 5 but less than or equal to 10. 9 is still the same. 10 is still greater than 5 but less than or equal to 10. But the moment we put in here 11, then now the value is greater than 10. So that is how you nest another if function, this time in the false the value if false if on the previous if function. Now let's try something a bit more challenging. Now let's try 4 outcomes within 3 logical tests. So you have here the first logical test. If this turns out to be true, then you proceed to another logical test, which will then evaluate true or false. If the first logical test is false, then it will evaluate to a third logical test, and then it will evaluate again true or false. So essentially, what you will have are 3 if functions. So you have the first if function with the first logical test, value if true 1, value if false 1. Then you have your second logical test 2, value if true 2, value if false 2. Then your third logical test, value if true 3, and value if false 3. Now, what we want to do right now is, as soon as the first logical test kicks in, when Microsoft Excel tests the first logical test, if this is true, we want the second logical test to be evaluated. If the first logical test is false, then we want the third logical test to be evaluated. If you've been following our discussion so far, you should have an idea of how this is supposed to work. Essentially, what you want to do is, you want to replace both value if true 1 and value if false 1 with if functions. In other words, the first if function branches out into 2 separate if functions, whether the first logical test turns out to be true or false. So what we do is, value if true 1 will be replaced by the second if function, and value if false 1 will be replaced by the third if function. So what you will have will look something like this. Now, I know what you can see on the screen for a lot of people can be very, very intimidating. It now looks a little less like an Excel function. It looks more like computer code. But if you've been following our discussion so far, you should be able to still understand what it says. So essentially, if logical test 1 turns out to be true, then you will see the second if function executed. But if logical test 1 turns out to be false, then you will see the third if function being executed. So this, what you're essentially doing is, you are nesting 2 if functions within 1 if function. Now, let's try that out with this diagram that you can see on the screen right now. So you have here 3 functions, 3 logical tests, which will evaluate into 4 different outcomes. So we start over here. If the value that given value is less than or equal to 50, if it's less than or equal to 50 and then it's true, then we evaluate if it is less than 10. So less than or equal to 50 and then further less than 10. If that is true, then the value is less than 10. If it is not less than 10, but of course it is already less than or equal to 50, but it is not less than 10, so therefore we want Excel to then go to this particular outcome, which says the value is between 10 and 50. Now, if this first logical test here is false, meaning the value is greater than 50, then Microsoft Excel can then execute this next logical test here. So it's greater than 50, but is it further greater than or equal to 100? If that is true, then we can execute this text here which says the value is greater than or equal to 100. But if that is false, then we can then display the value is greater than 50 but less than 100. So we're back here at our Microsoft Excel worksheet. So we have here our 4 outcomes, just like what we showed on our previous slide. And then we have here our conditions. And once again, we're supposed to do 3 logical tests, 3 if functions that we're supposed to nest together. So let's use, once again, this part, the bottom of the screen, as our scratch paper. Let's first do our first logical test. So, calling out the if function, if is this value over here less than or equal to 50? That is our logical test. If that turns out to be true, let's put in a placeholder over here. So let's say, let's put in the word true, like so, true. And if it is false, let's put another placeholder here. Let's make this say false, like so. Edit that typo over there, and we're done. Next, let's write the if function that we want to happen if the first if function turns out to be true. Let's write that down over here. If the first if function is true, this is the if function that we want to execute. So if, like so, the logical test will be, is this value less than 10? Like so. Now if that is true, then we want to display this value over here. It is less than 10. But if it is not less than 10, so that's the value false. If it is not less than 10, then we want Microsoft Excel to state this cell data, this text data over here in cell D5. So the value is between 10 and 50. Close that and then press enter. Next, let's write the if function that we want to display if the very first if function turns out to be false. So let's write that down here. So as a guide, then let's write down that if function. So if this cell over here is greater than or equal to 100, like so, then we want to display this cell here which says the value is greater than or equal to 100. And then if that is false, meaning the value is less than 100, then we want to display this outcome here. Whoops, that's supposed to be outcome D, not outcome C. So we want to display that there. Press enter. And then let's just change this to outcome D for correctness' sake. We now have 3 if statements. So this is the if statement if this turns out to be true, and this is the if statement if this turns out to be false. So once again, let's take this if statement and then copy this where the true is supposed to be, like so. And then let's copy this, like so, where the false is supposed to be, like so. Take this whole formula here and then transfer it to where it's supposed to be, like so. And now we have our finished if function, or rather nested if functions. So now let's take a look at what the finished if function looks like. So you have here first test, over here, first test if A2 is less than this cell, A2 is less than or equal to 50. If it is less than or equal to 50, then execute this if function over here. This function over here. So then further test if it is less than 10. If it is less than 10, display cell D2. If it is not less than 10, display D5. If this logical test turns out to be false, then execute this if function over here. So if cell A2 is greater than or equal to 100, then execute, or rather display cell D8. If it is false, display cell D11. Press enter, and then let's check if the nested if functions work. So far, the if function works as intended because this cell A2 is still blank, so therefore it has a value of 0, and the result still states the value is less than 10. So let's start inputting numbers here. Let's put in here 3. It's still less than 10. Let's put in here 5, still less than 10. Let's put in here 7, still less than 10. How about we put in here 10? The moment we put in here 10, the value is no longer less than 10. So we put in here 10. The value is between 10 and 50. So put in here 30, still between 10 and 50, 40, 50, still between 10 and 50, but the moment we put in here 51, it now says the value is greater than 50 but less than 100. 60, 75, 95, 100. The value is now greater than or equal to 100. So that is the nested if functions wherein both the true and the false branch out into different nested if functions. Now, let's use the nested if functions for something a bit more fun and something closer to what teachers are really experiencing out in the field. Let's use the nested if functions to convert numerical grades to letter grades. Now, I know that not all schools use letter grades when reporting student outcomes or student performance in their cards or in the performance records or whatever. But there are certain schools that do use letter grades. And of course, colleges do use letter grades. So let's use these letter grades as an example. Now, these letter grades, of course, may not be the same letter grades that your school is using. So you have here the grade legend, and then you have here the corresponding letter grades for those grades, grade ranges rather, and then you have here the descriptors. So if the grade is 94 to 100, you have an outstanding plus, and what's supposed to appear in the card or the report or whatever is supposed to be O+. If it is 93 to 90, O. 85 to 89, VS or very satisfactory. 80 to 84, S. 75 to 79, FS or fairly satisfactory. Anything below 75, in other words, failing grades, is D, or in the card, it can be translated to did not meet expectations. If you think of this in terms of the if function, you will now notice that there are 6 different outcomes. So 6 different outcomes. In our example so far, we've had 4 different outcomes. So this is a lot of if functions nested together. But before we think about the nesting of if functions, we first have to trace the train of thought. We first have to create the logic that will govern how we're going to write the if function. Now, there are many ways how to approach a problem like this, but this is personally how I prefer to do it. What you first want to do is, you want to first check the top. You want to first check each and every grade if the grade is greater than or equal to 94, which is the lowest part of the range of 94 to 100. Is the grade greater than or equal to 94? If it is greater than or equal to 94, then it's an O+. If it is not greater than or equal to 94, then check the grade again. And check again this time if it is greater than or equal to 90. If it is greater than or equal to 90, then it's O. If it is not, check again if it is greater than or equal to 85. If it is greater than or equal to 85, then it's a VS. If it is not, check again, etc., etc., etc. Essentially, if we want to translate the problem into an if function that will work for us, this is what the if function is going to look like if we convert that into a diagram form. So you want to check first, is the grade greater than or equal to 94? We start here. Is the grade greater than or equal to 94? If it is true, then Microsoft Excel displays O+. If it is false, therefore, it is less than 94. Of course, if it's not greater than or equal to 94, then therefore it's less than 94. So it's false. But if it is false, if it's less than 94, then check, is it greater than or equal to 90 despite being less than 94? So in other words, you're already checking within the range of less than 94 and greater than or equal to 90. If that is true, then it's going to be O. The grade is going to be O. If it is not greater than or equal to 90, then of course it's less than 90. So if it's less than 90, despite being less than 90, is it now greater than or equal to 85? So is it within that range? If the answer to that is another true, if it's another yes, then the grade is going to be VS or very satisfactory. If it is not, then therefore it's less than 85, so it's false. So I think you can start to see the pattern here. If it is false, then check again, is it greater than or equal to 80? If that is true, then that's S. If it is not, check again if it is greater than or equal to 75. If that is true, then fairly satisfactory or FS would be the letter grade. If it is not greater than or equal to 75, therefore it is less than 75. And less than 75 means a failing grade, which is in this school's case is a D. So this is how we're going to write our if function. You have 1, 2, 3, 4, 5 if functions nested as one. Now let's write that if function. So equals, and then call out the function name if, and then logical test. If this grade is greater than or equal to 94, then the letter grade value if true, if that is true, then the letter grade is O plus, like so. If that is false, then check again. Is the grade, that's cell B2, is the grade then greater than or equal to 90? If that is true, then the grade is O. If that is false, then check again. Is cell B2 greater than or equal to 85? Like so. If it is, then the grade is VS or very satisfactory. If it is not, check again. Getting very messy here. Next check, is the grade greater than or equal to, is cell B2 greater than or equal to 80? If it is, then the grade is S, like so. If it is not, check again. Is cell B2 greater than or equal to 75? If it is, then the grade is fairly satisfactory. If it is not, therefore it is lower than 75, then the grade is a D. So that is the final false statement. Let's finish up by covering the rest of the closing parenthesis for the rest of the if statements, and then press enter. We now have our letter grade. And as you can see here, FS 78 does translate to fairly satisfactory, just like what you can see on the legend on the right. And because we only used relative references in this formula, we can simply safely copy that, paste it all the way down here to apply to all of these cells here, and we now have in seconds the corresponding letter grade for these numerical grades. So let's do a few random checking. So 78 is FS, that 78 is 75 to 79, so that's FS. 84 is within 80 to 84, so that's an S, correct. 91 is between 90 to 93, so that's an O, correct. So yeah, so far we've done our job here. So that is the power of nested if functions, being able to process, in this case, 200 pieces of data in mere seconds just by knowing if and nested if functions. Now I know that some of you who are watching this video may be starting to think that this is hard to understand. Grasping nested if functions is hard to understand. But in response to that, let me just clarify that learning nested if functions is actually easy to understand. I hope in this video you've understood nested if functions, replacing the value if true and value if false with if functions. That part is easy to understand. But I do understand that creating the logic, creating the train of thought as to how to arrange the if functions, that part is difficult, even for intermediate and advanced users of Microsoft Excel. So all I can say regarding that is learn, practice, test, and debug. Learn, practice, test, and debug. Keep on learning Microsoft Excel. Keep on practicing using the if functions. Once you build the if function or the nested if functions, test them out so that you can cover all of the necessary outcomes that you need. And then continue to debug until you get the if function that you want. Now, so far, regarding the if function, we have already been manipulating the value if true and the value if false. We've tried inserting constant values, constant text. We've tried inserting other functions. And in fact, we've even started using other if functions to replace these value if true or value if false arguments. But please note that the if function is far more versatile than that. So far, for the logical tests, we've only been using the basic logical operators. We've only been using equals, not equal to, greater than, less than, greater than or equal to, lot less than equal to, but there are far more possible logical tests than just the basic logical operators. To give you examples of logical tests that are not basic logical operators, For example, you can ask Microsoft Excel to check if a number is an odd number, or if a number is an even number, or if data in a cell is text, or if data in a cell is a number. Or as another example, you can have Microsoft Excel check multiple logical tests and only one of them should be true. Or you can even ask Microsoft Excel to check multiple logical tests and all of them should be true. The more complex logical tests, those that are not simple basic logical operators, are actually the topics of our next lessons. When we finally get to the logical functions, we have the exact, the not, the true, the false, the and, the or, and of course the is series of logical operators. Those are the topics of our next lessons. And mind you, I hope you're not intimidated by them as you hear me talk about them. They're not hard to understand. You just have to learn them and practice them. And once again, they're going to be discussed in future lessons in the If series in this channel. So once again, please subscribe to the channel so that you don't miss those lessons when they come. Now, of course, some of you may wonder, wow, you can actually string 1, 2, 3, 4, 5, 6 if functions together. Does that mean you have an infinite number, you can nest an infinite number of if functions together? Actually, the answer is no. Actually, Microsoft Excel itself states that you have a limit of 64. You can only string 64 if functions together, meaning you have a limit of nesting 64 if functions. But to be honest, personally, as a user of Microsoft Excel, I have never ever needed to nest 64 if functions together because there are other better and more efficient ways to do complex decision making. You can even do decision making with hundreds or even thousands of outcomes. And how do you do that? You do that by learning how to use the if function in combination with the COUNTIF function, the VLOOKUP function, the HLOOKUP function, the index function, and the match function. And all of those functions and lessons and more will be discussed in future episodes of this channel. So once again, please subscribe to the channel so that you don't miss those lessons when they come. So that's it for our lesson on nested if functions. I hope I earned your subscription today. Once again, I am Carlo and this is Carlo Excels. Thank you very much for watching.